Alright, so in this video, I'm going to be talking about string parsing. And all that string parsing basically is it's just a way to take some string and break it down into smaller components or substrings that we can then use to read or analyze or rearrange or maybe reconstruct a new string or validate the string. There's a whole bunch of things that we can do with the information that we get by breaking down a string. And there are many, many ways to parse a string. There's a syntax known as regex, or also known as regular expressions, which is almost kind of like a sub-language that we use to tell our program what patterns we're looking for in a string. But there are also built-in methods for parsing a string. For example, I have some ordinary string here, and there are some just base methods in Java, for example. So I could say str.contains. Contains is a way of parsing a string. This is essentially how I can check to see if there is some character sequence that exists within my string. I can do string.replace. This is a method that will take as one input the sequence of characters that you want to find in your string. So maybe I want to find the word sum, and then the second argument is the word that you want to replace the first argument with. So maybe I can put the as my replacement for the word sum, and if I log this into the terminal, then we should see that the output is, oops, actually I have to save this first and then run this. You can see we get the ordinary string. So this is a way of parsing a string and then creating a new string with the information that we just used. And in this case, that new string is just some mutated version of our original string. So because there are so many ways to parse these data types, I'm just going to be covering the very basics in this video, and I want to mostly focus on just using a for loop to iterate over every single character in a string, just so we can kind of see the potential of what we get by doing that. So I'm just going to create a basic numeric for loop here, starting at index I equals 0, and we want this to continue looping while I is less than, we're going to actually use string.length. So typically when you're parsing a string, the length method is going to be very useful because we want to traverse over every single element or character in a string, which is either going to be from 0 to the entire length of the string, or maybe we want to look at the halfway mark through the string, so we might say, I don't know, string.length divided by 2 if we just want to parse over the first half of it. But either way, the length of the string is going to play probably, most likely, an important factor in your parsing. And then let's just increment I by 1 every single iteration. And now we can start to make some pretty interesting observations. So one very powerful method of the string object is the char@at method. So for example, if I say system.out.println string.char@, this method allows us to find any individual character within a string given its index in that string or position in that string. And it's very important to remember that when we're indexing a string by using char@at or other methods, the string always starts at 0. So the first character in the string is not going to be at index 1, it's actually going to be at index 0. So it's just a very common point of confusion that arises when it comes to indexing or parsing strings. So if I run this, we should see in the output window that we get s, since s is at the first index or the 0th index in our string using the char@at method. And so now we can notice that if I increase the 0 here to 1, right, and I run this, then we get the second character in the string. If I increase this to the number 2 and I run this, then we get the third character in the string, right? And we can keep doing this over and over and over again until we reach the end of the string, at which point we've accessed every single individual character in the string. And so we can automate this process instead of doing it manually by using a for loop, because what variable do we know that's constantly increasing as it's cycling a controlled number of times? Well, that's the I variable in our for loop, right? I is increasing by 1 every single cycle of the loop up until the end of the length of the string. So we could actually copy this code here, and we could automate printing every individual character in this string by saying system.out.print string.char@, and then we're going to replace our index with I. So I will be constantly changing, constantly incrementing, linearly, one by one, and that will give us an output of every single character on a new line of whatever string that we are indexing. So this is a form of string parsing, because now we can do special operations on these individual characters to maybe, for example, do input validation. So maybe I don't want to have the letter A in my string. Well, now that I know that I can get each individual character using string.char@index I can create a variable for this, and we'll just call it character equals, oops, should not be an equal sign here. Char character equals string.char@index I. And now we can just check and see what the properties of this character are. So if I don't want to have the letter A in my string, then I can just create an if statement in here and say if character is equal to, and I'm going to compare it to a lowercase a, so let's just use a lowercase a here. Then maybe I can print out some message here that says string cannot contain letter A. And then I can break out of the for loop. And so if I run this, then we should see that we get this error message, or this, in this case, just a regular print message, but it's containing an error saying that we cannot have the letter A in our string. And if I remove the only A in this string, right here, and then I run this, you can see we don't get that message. So this is a form of string validation, or input validation, if a user was inputting this text. And this is a very basic way of checking to see if whether or not that string is valid. A more general and probably realistic example might be maybe wanting to not have any numbers in our string. So maybe we're prompting the user for some text input, and we don't want them to have any numbers within that text input for whatever reason. So we could just as easily, just as before, create an if statement. This time we could use the character.isDigit method, and we can pass the character to this. And the isDigit method will return true if whatever character we passed is a digit between 0 and 9. So it'll be false if otherwise. So we can say if the character is a digit, then again we can break out of our for loop, and maybe we can add a system print here, system.out.print. We can say string cannot contain a number. And if I run this, we should see that it outputs nothing because our string passed, we have no numbers in it. But if I add any digit anywhere in this string, maybe I'll put it like right here, and then I run this program, you see we now get this error message saying string cannot contain a number, because in this if statement, when we're checking all of the individual characters, it finds a digit at this index. And we can actually print out to see what index exactly it found the digit at. So maybe I could come down here and we can say string cannot contain a number. We found a number at, and then whatever the current index is. So if I run this, it says string cannot contain a number. We found a number at index 17. And just to make this easier to kind of test here, I'm going to move the digit closer to the start of the string. So now it says we found a number at index 1. And of course we know that strings start at 0, so when it says index 1, it's really talking about right here. If you were going to output this to the console, then you might want to do something like, say, I plus 1, just so it's a bit more sensible to the reader so they can see what position in the string the character is actually at. And another cool thing we can do with parsing a string using a for loop is we're not limited to just counting over every individual character in the string one by one in consecutive order. We could actually, for example, maybe we want to only look at every other character in the string. So how could we do that? Well, we could start our indexer, or our counter, at 0, which is at the first position of the string, and then instead of increasing I by 1 every single time, we could increase I by 2. So we could say I plus equals 2, and this will give us every other character in the string. And so if I print this in the output window, .println character, you'll see that the result that we get is, starting at S, we're printing every other character in the string. So we start at S, we skip over O, we get M, we skip over E, we get a space character, we skip over the letter O, we get R, and the process continues. And this is a pretty nice kind of built-in way to check every other character in our string by modifying our counter variable within our for loop. But let's say, for example, maybe you also want to check every third character or some other pattern that's more beneficial when I is incrementing by 1. So in a case like that, we could actually just go back to having our regular for loop pattern that we had before, which is just I starting at 0 and then incrementing by 1 every single time. And we can implement the exact same strategy of locating every other character in the string by just using an if statement to check what our variable I is at. So let's say, in this case, I is representing the position of the character in the string. So I can say if I mod 2 is equal to 0, then, in other words, I mod 2 will return 0 if I is even. So we're saying if the position of the character in the string is even, then we can do some logic to it. So in this case, I'm just going to say system.out.print. We'll say character is at position, and then we'll just pass it the value of I. And so if I run this, you'll see we get the exact same list of characters here, but of course with just our modified string. So if I run this, you'll see we have character, S, M, R, I, and all of the same characters we had before is being displayed, and also their respective positions. And since I'm not relying on changing the value of I directly within the statement of our for loop, I still have access to the consecutive changing of the value of I to do other checks with. So maybe I want to add another string parsing pattern down here that's checking every third character. So I could say something like if I mod 3 is equal to 0, then I can say, we'll just copy and paste this, and we'll say this character is the next third character in the string. And now if I run this, you'll see every third character. So we're going to start, I'm actually going to take this out just so that we can see this a bit better. But you can see we start at our first character, and then we wait 2 more iterations, right? So we have O, and then M, and then E. So E is our next third character in the string. Then we look at our space, which counts as 1. We have 1, 2, 3. So then we have R as our next third character, and then obviously the process continues. And so all of this is just to say that in some cases, you may just want to have an ordinary for loop that just counts consecutively throughout the length of your string so that you can do other checks that may involve different patterns for however you're parsing the string in the body of your for loop. Anyways, I think that's going to be it for this video. I really just wanted to give an example of string parsing using a for loop at the very basic level, just iterating over all of the characters in a string and just showing that you can manipulate them and use the counting variable to keep track of wherever place you are in the string and stuff like that. So hopefully this video was of some help, and I will see you in the next one.